Over the past 2 months, I've changed my entire data strategy, and the biggest upgrade was actually my Offsite NAS for backups. In this video, I'll show you how I rebuilt it to keep everything encrypted end-to-end, use block-level replication for tiny, frequent transfers, and verify restores so I know it actually works. I'll walk through my old process, the new setup and schedules, and the key lessons that helped me build the best offsite backup that I've ever had. So for a second, we have to talk about my current setup. So for a while, I was using a Synology NAS. As I was migrating everything over to TrueNAS, I ran them in parallel for about 6 months or so. When I was using my Synology NAS, I used Hyper Backup. Hyper Backup was a great utility, but unfortunately it was very slow and transfers took a lot of time. In that transition period where I was using Synology and TrueNAS, I used my Ugreen NAS as an offsite backup. So I was using a DXP 8800 Plus, and I was basically just using the default backup tool that they have, which is an rsync backup, and I was pulling the data from my on-site NAS devices to that offsite Ugreen NAS, and I was using snapshots for data integrity purposes. The rsync backups were fast, it worked very well overall, but there were a few things that it was missing, and the key was that I wanted all of the data to be encrypted at rest, and unfortunately, it wasn't. That forced me to look at the overall data strategy that I was using, and it finally made sense that I should just install TrueNAS on that DXP 8800 Plus so that I could use ZFS replication, and that's what I did. ZFS replication will actually be done at a block level, which means they will be very, very fast and efficient, and I can do them more frequently than I was. But the key is that we're not really replicating the data itself, we're replicating snapshots, but we'll talk more about that later. The next benefit is that the data will be encrypted at rest. So if someone comes and takes that physical NAS device, the hard drives, anything from it, all of the data will be encrypted and they will not be able to access anything. Next, it will allow me to use something called pull replication. So rather than pushing the data from the on-site NAS to the off-site NAS, I will actually be pulling those snapshots from the on-site NAS to the off-site NAS. So no credentials will be stored on the on-site NAS. Everything will be done from the off-site NAS. So now that we got that out of the way, let's look at how to configure this. So this is my on-site NAS device. This is the NAS that I have at my house. And the way that I structured my data sets is very important. So what you can see is that everything is encrypted, but it's unlocked by default. So we have a test replication data set here. We're using this for testing purposes, but these two are the ones we're going to talk about. So the way I structured this is that the data set will store all of the data that I want replicated to the offsite NAS. This is all the data that I have that will on a regular basis be replicated to the offsite NAS. The local data set is going to be done for data that I am keeping local. This is data that will not be replicated. What this will allow me to do is replicate the top level data set and then in essence replicate everything underneath it recursively, ensuring that if I add anything new, it will automatically be done. To show you how this works, I'll be using this test replication dataset that I created, which basically is the same format and structure as the others, but a very small amount of data so that it will run fast. So like I said earlier, the credentials for this replication will not exist on this on-site NAS device. So what I mean by that is if you go into the backup credentials here, you will not be able to access the offsite NAS from the on-site NAS. We're going to be accessing it from the offsite NAS to the on-site NAS. But with that said, what we have to do is we have to create a user account so that the offsite NAS can authenticate and access the data on the on-site NAS. Now, technically, you can use the root user for this, but the reason we don't want to do that is because if for whatever reason that offsite NAS was compromised, technically it would have unrestricted access to the on-site NAS, so we really don't want to do that. So instead, what we're going to do is we are going to create a new user for this. And what we're going to do is add a new user, and I'm just going to call it ZFS Rep. Now, there's a few things that we have to do for this ZFS replication user. And the first thing is we're going to disable the password because we do not want to use SSH with password authentication. We want to use an SSH key. So we're going to disable a password. You will not be able to log into this account with a password. The next thing we're going to do is we're going to scroll down here and we're going to have to create a home directory. Now we have to create a home directory because technically the SSH key will be stored there. So I'm going to select my home directories folder and then I'm going to ensure that this create home directory checkbox is enabled. The next thing we're going to do is in the shell, I'm going to change this to bash. And then this is very important here. So allowed sudo commands with no password. So what we're going to do here is add this path. And what it's going to allow us to do is run ZFS replication without a password. So make sure that's there. We are going to uncheck SMB user and then everything else here can stay as default. We're going to save this account. And now the user that we're going to be using for the ZFS replication process has been created. But we have to ensure that we can access the on-site NAS from the off-site NAS. Now, right now, everything is local, but a little later in this video, this NAS device will be in a simulated off-site environment behind another firewall. So this is the quote-unquote off-site NAS that we want to use to store the data. So this is a test NAS right now. When this is really done, I'll have all of the data replicated over. So the first thing we're going to do is inside of the credentials section here, we're going to go to backup credentials and we're going to create a new SSH connection. And what I'm going to do is just call this ZFS rep and I'm going to change this to manual. So in the host here, I'm going to type in the IP address of that on-site NAS device. The port here, 22, is fine. We are going to change this to be the username that we created on the on-site NAS. So this is ZFS rep. And then I'm going to generate a new private key. And then the last thing that we have to do is we have to discover the remote host key and it should automatically find that and then you can save this. And then if we refresh this page, what you'll see is a new key pair has been created. We can edit this and we can copy this public key. Now this public key has to be added to the user account of the ZFS replication user on the on-site NAS. So we're going to go back and we're going to edit that. And then in the authorized keys section here, we're going to paste this in and then we're going to save this. So now that that's done, what we have to do is we have to create our replication task. Now, like I said earlier, you're not actually replicating the data itself. What you're doing is you're replicating snapshots. And it's very powerful because you're really replicating a point in time. So the file is basically frozen at a point in time, and that is what will be replicated. So it's better from a data integrity perspective. So the key there is snapshots. So if we come back to our on-site NAS device here, what I'm going to do is I'm going to set up a new snapshot task. I'm just going to do this so that it runs every minute so we have data to replicate. What I'm going to do is scroll down to that test replication data set that I created, and I'm going to set it to be recursive. So it's basically everything inside of that data set. Now, if we look at the data sets themselves, you will see that it's basically this top level data set and everything underneath it. So when I do this for real, I'm going to be doing it for the data set, and then everything underneath it will automatically be replicated. So I'm going to change this from daily to, I'm just going to do every minute right now, which is to ensure that we have some data. And then I'm going to select this naming scheme because this is going to end up being very important. The naming scheme is what we will use to determine the exact snapshots that we want to replicate. So I'm going to save this, and then we can head back to our offsite NAS device, go to data protection, and now we can start to create our replication task. So inside of the replication wizard, I'm immediately going to go to the advanced option here. And I'm just going to call this on-site NAS. And then the SSH connection, we're going to select that SSH connection that we used. And what you're going to see is that it's going to suggest that you use sudo for ZFS commands. Now, because this is not an admin account, we have to use this. So we're going to select use, and then that just ensures that replication will run without any problems. Then next, the direction. Remember, we said push versus pull. Push would push the data, pull will pull the data. So we're going to pull the data with our offsite NAS, and we're going to pull that data from our onsite NAS. So I'm going to select pull here, and then we're going to have to scroll down. So now we have to configure our source and destination. So if we expand source, what you will see is that we're going to get to the data that is currently on our onsite NAS, again, because we are pulling that data. So what I'm going to do is I'm going to select test replication here, because that is the top level folder. And then the important part here is to ensure that it is recursive, because that will ensure that it pulls everything below it. The next thing we're going to do is I'm going to select this data set here, and then you have to type in exactly what you want it to be called. So you're actually physically going to type in what you want it to be. I'm going to be replicating the test replication dataset to a test replication dataset. Now, scrolling down here, what you're going to see is the destination dataset read-only policy. So I'm going to set this to set. And what this is going to ensure is that basically every time this replication task runs, it will ensure that the dataset gets set to read-only. So if you wanted to edit the data, you would have to physically turn read-only to be off. Now, a few other things to be aware of here. Encryption. We are not going to enable encryption. Remember, our dataset is currently encrypted, and this include dataset properties option here will bring over that encrypted dataset. Next, replication from scratch. If this was enabled, if someone was to go on the Offsite NAS and delete any of the snapshots, it would technically replicate. If you keep this off, which I'd suggest that you do, the task itself will error out. Now, next, our snapshot retention policy. So we don't want to use the same as the source, because that would say that whatever exists on the source is going to exist on our Offsite NAS as well. We don't want that. We're going to do custom. For me, I'm just going to do 4 weeks, but this will ensure that the snapshots on this Offsite NAS will not be impacted by anything on the Onsite NAS, and they will be stored for 4 weeks. Now, the last thing that we have to do is match the specific snapshots that we want to replicate. So that's where this matching naming schema comes in. So I'm going to go in and paste that naming schema that we copied earlier. And this is going to ensure that we're only pulling those specific snapshots. Now, remember, you can make this whatever you want it to be. I'm just using the default option. And then I'm going to uncheck everything here because this is a test. But what you'd really want to do is set up a schedule. And that's what I'll be doing on my production environment. So with that done, I'm going to save this. So at this point, we have snapshots configured on the Onsite NAS. They are currently running. We configured our replication task in the Offsite NAS, which is pulling those snapshots from the Onsite NAS. And if we come here and we run this, you will see that the task is currently running and it is pulling those snapshots. Now, it's pulling a lot of snapshots because I was running this for testing purposes. So we're going to wait a second here, and we're going to see what happens when all of these snapshots replicate. Okay, so the replication task just finished, and everything has now been transferred over to the Offsite NAS device. So if I go to datasets, what you'll see is that this test replication dataset exists, and it's basically a mirror of what we have in our current Onsite NAS device. The difference is that it is unlocked here, and it is locked here. Now, I'm never going to unlock it. There's no reason for me to ever unlock it. I am going to keep this data encrypted at rest on this Offsite NAS device. This ensures that if anyone physically takes the drives or the NAS device itself, the data is encrypted. You cannot get to it. Now, technically, if I wanted to, I could go in and I could unlock the data sets. And I'd basically just use the key or the passphrase itself, and that would ensure that the data gets unlocked. And at that point, the data on this Offsite NAS would be accessible. But let's say I never wanted to do that. And let's use a real example here. This is how I'm going to treat this if the situation ever arises where I have to restore data. So in my Onsite NAS here, what I'm going to do is I'm just going to come in here and I am going to delete this data set. So the data was deleted, it's gone. Whatever happens, it's now gone. What I'm going to do is on the Offsite NAS, I'm going to create a new task. And this is where I'll use a push task. But what I'll do is I will create a new replication task. I'm going to call it test replication. I'm going to select that same SSH connection that we used. But the difference is going to be I'm going to push the data. From there, I can then select my test replication folder, ensure that recursive is on. I'm going to type in my test replication again. The destination dataset read-only in this case does not matter. Just ensure that recursive is on. For the snapshot retention policy, you could set this to be the same as the source. Then we have to type in that same naming schema that we used. So for whatever reason, I've been running into this error here. It just basically says it can't access the snapshots. We're just going to save this and then we're going to run it. And once it's running, what you'll see is the snapshots are starting to send. And if we come back to our NAS, you'll see that the data set is being rebuilt. If we wait, we'll have our child data set as well. So with the replication task complete, what you will see is that the data set is now there, but it's locked. So what we have to do is unlock it, and we have to actually unlock both of them. But now that it's unlocked, the final thing we'd want to do is edit the ZFS encryption, and we would want to inherit it from our parent. And once you do that for both of them, what you'll see is that we are right back to where we were. So the snapshots were sent to our offsite NAS device. The data was deleted entirely on our onsite NAS device, and then we restored it by pushing it back from our offsite NAS to our onsite NAS. So this all works really well. But the biggest problem that we're going to have right now is the fact that the offsite NAS has to access our onsite NAS. So it works a little different than it would traditionally, because normally all you really need to do is push the data from your onsite NAS to your offsite NAS. But in this case, we're pulling the data from our offsite NAS with the data living on our onsite NAS. So there are a lot of different ways that you could do this, but what I decided is best is to use a zero trust network like Twingate, who is the sponsor of today's video. Now I picked Twingate specifically for this because I didn't want the offsite NAS to have unrestricted access to either my local network or even the NAS itself. So I want a management layer inside, in between that basically says you can access the onsite NAS, but you can only do it using port 22, which is SSH. That will allow us to basically replicate all of our snapshots, restore the data if we ever had to, but it won't be able to access anything else. So this is arguably the most important portion of this video because we have to make sure that that offsite NAS can access the onsite NAS, and that's what we're going to jump into. So we are in Twingate right now, and the first thing that we have to do is deploy a connector. Now, if you've already used Twingate and you've already set up a connector, you can skip over this portion. If you haven't, the connector is what's going to allow us to basically connect back to our local network with our offsite NAS. So the offsite NAS will automatically be able to connect to our onsite NAS. So I already have a remote network set up, and it's basically just my home network. But what you'll see is I only have one connector. Now that one connector is exposing Nextcloud. I have a video for that if you're interested. But what's cool about Twingate is they allow you to deploy two different connectors for high availability. So what we're going to do is we're going to deploy this second connector here. And I am going to deploy this inside of Proxmox. So I'm going to select Proxmox here. And then this is a command that we can run inside of Proxmox. So I'm going to copy that command, and then I am going to generate the tokens here, and you have to authenticate first. And now we have our token. So before we go to Proxmox, I want to show that you could realistically configure this on any of these, just walk through the instructions, but I'm going to show you quickly how Proxmox works. And basically inside of the shell, I'm just going to paste in that command, and it's going to run through and just configure this for us. So I am not going to send the diagnostics. I'm going to use the default settings. This is the storage for the container itself. So I'm going to use my NAS. I'm going to use VM data for the container itself. And then it's going to run through and basically download everything. Couldn't find the network, so it's going to use the default DNS servers, which is fine. Okay, so here it says, please enter your access token. So we're going to go back and we're going to copy that access token. We're going to paste it in. We're going to press enter. It's going to ask for the refresh token. We're going to paste it in and press enter, and then our network name. And now it will set up the Twingate connector. All right, so that is done. So if we head back to Twingate, you'll see that we are now connected. So I have two of them that are now connected. So this is just the connector. What we really have to do at this point is we have to configure a client. Now, if this was a device that we'd be interacting with regularly, what we would do is we'd download the Twingate app and access it that way. But this is going to be a little different. So what we actually have to do is we have to create a service. So what we're going to do is we're going to create a service for TrueNAS. So we're going to create a new service here. I'm going to call it TrueNAS Offsite, and then we're going to create the service account. Now, if we click inside of here, we have to generate a key. As soon as we do that, it will set an expiration period. I want this to be indefinite and not expire, so I'm going to set that to 0, and then I'm going to generate. Now, this is the important part. This is going to generate a service key. We're going to have to use this on our offsite NAS. So I'm going to copy this, and then I'm going to save and close. Once you save and close, you cannot get that back. So inside of TrueNAS, I created an apps directory, and this apps directory is where I'll store my Docker configurations. So I'm going to create a new data set underneath it, and I'm just going to call it Twingate. The only important point here is you need to select apps. This will ensure that all the permissions on the data set are correct. So I'm going to save this, and now we have our new data set. So what we have to do inside of this data set is we have to actually create a file with that JSON information. So I'm going to go into the shell. And what I'm going to do is I'm going to navigate to that Twingate data set that we created, and I'm going to create a new file called servicekey.json. And inside of there, I'm going to paste in all of that information. So this is what will be used to connect back to my Twingate network. So I'm going to save that. And now we can go into the apps section, and we're basically just going to create a custom application. I'm going to call it Twingate Client. And I'm going to paste this in. The key is that this volume here has to point back to that JSON file that we created. Everything else can stay as default. The only thing I changed is I set the network mode to be host. I'm going to save this. And after a minute or so, the Twingate client will be connected. Now, as of right now, this is a lab environment, but this TrueNAS instance cannot access my on-site NAS. So if I come to data protection and I try and run that replication task that we created earlier, it's not going to work. And it's eventually going to fail because it can't actually access my NAS. And there you go. It is unable to connect. The reason is because on the Twingate side, Twingate is a zero trust network. So what we have to actually do is we have to explicitly allow access to that resource. So this is Nextcloud that is currently configured. But I can add a new resource here. I can call this TrueNAS. I can put the IP address in here, but I don't want it to access all ports. I only want it to access 22. And I'm going to block UDP traffic, and I'm going to block ICMP. It doesn't need access to anything. So I'm going to create this resource. Then I have to specify exactly what can access it. So TrueNAS offsite should be able to access TrueNAS onsite. We're going to grant access. And then we are going to head back to the offsite NAS. So it failed. We are going to run the job again. And what you'll see is that the snapshots now are starting to sync. So on the Twingate side, the only thing we really did is we allowed access that was not previously granted. And that's really the power of a zero trust network. Rather than a traditional VPN that has access to everything, we specified exactly what it could access. So it can access TrueNAS on-site on port 22, but that is it. So to kind of recap everything we did in this video, because I know it was a long video, we basically went in and we configured TrueNAS to not only take snapshots, but replicate those snapshots. Those snapshots that get replicated are pulled. So our offsite NAS pulls snapshots from our on-site NAS. It has a custom retention policy, which means that it will basically not delete snapshots if the source data gets deleted for whatever reason. We have a different account that's running it, so realistically, the on-site NAS cannot connect to the offsite NAS. The offsite NAS's credentials cannot do anything if it could access the on-site NAS. And then we configured Twingate so that it could access the NAS on port 22 to be able to do the ZFS replication, but it can't do anything else. And best of all, the data on that offsite NAS is encrypted at rest. So if anyone was to get it, they cannot physically do anything with it. Now, when I set this up in my production environment, I'm going to have that replication running pretty frequently. I'm probably going to do once an hour. Compare that to my old setup, which was running once a day at best. And you could see the pretty significant difference in terms of data integrity and just a general rollback plan that I'll have now that I didn't have before. So I know this was a lot. We went over a lot in this video. But if you have any questions, please feel free to leave those in the comments. But other than that, if you made it this far, thank you very much for watching. I'll see you guys next time.